Welcome to PV Online Chemistry. Now what we're going to do is we're going to combine both Boyle's law and Charles' law in what we call the combination gas law. And that's going to be combining volume, pressure, and temperature changes. So let's take a look at this. We have a scuba diver, and their lungs have a volume of 3.6 liters at 310 Kelvin at 1 atmosphere. So that's probably when they're before they jump into the ocean. Now, in this first sentence, that's giving you the first state. In other words, we want to call this V1, T1, and P1. It's very important that we keep the values for each of the variables together. So I've got 3.6 liters as my volume. The liters is the hint that it's a volume. 310 Kelvin. The Kelvin should be a hint that that's going to be our temperature. And the pressure is going to be the 1 atmosphere, with the atmosphere giving us the hint. Now the question is, what is the volume? So that's going to be our unknown. That's what we're looking for. So what is the volume of the scuba diver's lungs when they're at 308 Kelvin? So they've gone to a place a little bit colder, 308 Kelvin, and at 2 atmospheres. So now they're feeling a lot more pressure, and that's due to the weight of the water on top of them as well. So we've got the 2 atmospheres. So I've made sure that I had all my variables paired up the way they should for each condition. Now we need to choose the equation that's going to help us solve the problem. Since it's a combination gas law, it's going to be Boyle's law combined with Charles' law. Well, Boyle's law was P1V1 equals P2V2, and Charles' law was V1 over T1 equals V2 over T2. So this will satisfy our requirement for the combination gas law. Okay, now we need to select the appropriate rearranged equation to solve for our unknown. Well, we're looking for V2, and that's for each case, they've got that. So now let's take a look at this. What are you going to have to do to T2 to get rid of it? And you'll recognize that you need to multiply both sides by T2. So I'm going to have P1 V1 T2 in the numerator. Well, right off the bat, you should see that this is the only one that gives us that condition. But let's just verify it and look at P2. I need to divide both sides by P2, which means in the rearranged equation, P2 will be in the denominator. So we select this guy, and we're good. Now, once you've listed all your variables and you've got the equation rearranged, now it's going to be just a bit of substitution. So P1 is going to be the 1 atmosphere, so we place that there. V1 is going to be the 3.6 liters. Oops, I better pick the volume. And T1, now be careful. T1 isn't in the numerator, but it's in the denominator. The second pressure is going to be 2 atmospheres, and the second temperature will be 308 Kelvin. So now we're ready. Now let's determine what unit our answer will be in. Take a look at your equation, and since we've got all the units there, you should be able to quickly determine which ones are going to cancel out. In order to cancel out, they have to be both in the numerator and denominator. You'll see that the pressure, the atmosphere, is in the numerator, it's in the denominator, as is the Kelvin. The Kelvin's in the numerator and denominator, leaving us only with liters. Now, milliliters is appropriate volume, but since we started with liters, that was what our answer is going to be in, is liters. Now we're ready to solve. So all we need to do is plug in our values. Now remember, anything that's in the numerator we're going to multiply, and anything in the denominator is going to be divided. We're going to divide that. So I put this in my calculator, and I'm going to put in 1.79. Now look at what happens here. That was marked incorrect. And that's because I've got 3 significant figures here, but only 2 with my volume. So using appropriate significant figures, my solution will actually be 1.8. I submit it, and now it's correct. Good luck.